So now we will start part 2 with Python language basics. First of all, what exactly is GeoPython? We have seen and run Python macros, and we even added a variable, but apparently we did not really mention GeoPython. GeoPython is an interpreter for Python 3.6, so that any regular Python script should run in GeoDict. However, GeoPython gives access to GeoDict-specific functions. They are called the GeoPython Application Program Interface, short API. They all can be recognized by the prefix GD. In fact, we've already seen GeoDict-specific functions. The first one was the GD runCMD that is used to run the commands which are saved from the user interface. This function was used to run the fiber geocreation command to generate the fiber structure. The second API function we've seen is the GD MSG box, which shows a nice message dialog. To start with Python, we suggest to record a Python macro in GeoDict, as we have done together. Then we can use variables and varimacro for parameter studies. In the following, we show you some useful Python language basics. They will help you to make parametric macros even more useful. I will type them together with you in the editor. So open the editor again and open a new file. File, new, and we will save it as output file. Therefore click on File, Save As. Again, make sure that it's in your project folder and call it output py. If you don't have Notepad++, you have to choose the Python as a type. Then click on Save. The first Python language basic that I will show you is text output. This can be very useful for debugging. Imagine, for example, a Python script does not produce the expected results. Then it would be good to know where exactly the error happens. By printing the intermediate results, this can be found out. In this workshop, we will show you two possibilities to print text output. In this workshop, we will show you two possibilities for this purpose. The first one is a GeoDict-specific function. So it starts with GD dot and then MSG box. This stands for message box. And then inside the braces, we enter the output. In this case, it will be a string. So, for example, hello world. So a string is always marked with quotation marks in Python. It can also be double quotation marks. But you have to be sure that it's the same in the beginning and in the end. You can also output integers like 42. So you can output most basic Python values like strings and integers and floating points. And this function will show a message box with the message that is inside here, the braces, and you have an OK button to close the dialog again. The second one is a Python command which is called print. And here, as done before with the message box, the content that will be printed has to be inside the braces. This content will be printed into the console of GeoDict. So here again, we will print hello world. Again, make sure that you have a quotation mark in the front and in the end. So click Save. And go back to the macro execution control by running to GeoDict and then macro, execute macro script, click on refresh, and here the output macro appears. So it don't have parameters, so the parameters button is grayed out. And here no preview is available because it is has Python syntax beyond of the normal GeoDict commands. So we click on run, and here the first message box appears. If we click in the box, then here the countdown stops. At the end of the countdown, the box would be closed automatically. So you see here the first message. We click OK, and then the second message appears with the 42. Click OK again. And for the third message, we have to look at the console. It's here in the bottom of the GeoDict user interface. To unfold the console, click on the double arrow here in the right, and you can see here also the two message box, which is always the 3 lines here, and here the single line is from the print command, the hello world. So if you want to have text output, but you do not want to interrupt the macro execution with message dialogues, the print command would be preferable. So next I will show you how variables work in Python. Therefore we open a new file again, with file new, and we will save this file as variables. So again, make sure that you save the macro in your project folder and as a Python file. And click Save. Any type of data can be stored into a variable. We had the example earlier of defining the parameter called GDSVP. All of the parameters declared like this in the variables section automatically appear as a Python variable in your macro. They will have the value given in the user interface. Variables can also be defined wherever it is needed in the script. We only need a name and some value. Of course, then they do not appear in the user interface. But that is not necessary for each variable. We also had the example of a variable of the type before. The Python dictionary, where the parameters for the generation of the fiber structure were saved, was also assigned to a variable. It was called fiberGeoCreateArgs1. This was needed to execute the command for the fiber structure generation. So a variable is defined the moment it is first assigned. So for example, if we call a variable a and assign the value 42, then from now on a is 42. We can show it with a message box. So now we only have to write the name of the variable inside the braces, and then 42 will be displayed. Also, arithmetics would work as expected. So for example, if we call the second variable b and assign the value a plus 1, then from now on b will be 43. You can also show it in the message box. Also, the value of a variable can be replaced by a new value. So if you know assign a new value to a, then from now on a would be another value. But for the assigning process, you can also use the old a, for example a times 2. Then here on the right side, a is still the 42, but from now on a would be 84. So we also will output this in the message box. And the last one will be a string. So we call it s, and we assign the string hello world. again. And we will also output this. And we will save it. And go back to the macro execution control and click refresh. And here it appeared. As the output file, it has no parameters and you have no preview. But when you click on run, then you see here the 42, which was the A. The second one is the B, which with the value of 43. And then the new A, this is 84. And last but not least, the string hello world. So now we want to take care of the issue that in our parameter study, all structures were saved under the same name, FiberGeoDDR. And we had to rename it for each generation. So our goal is to make the parameter value part of the result file name. We find the file name in the parameters dictionary. So therefore, we have to go back to our workshop 2 file and then search for the result file name. Here it is. For me, it's line 147. And here we have the result file FiberGeoDDR. So to achieve our goal, we will start with an F in front of the string. This stands for format. So now we can format the string as we want to with, for example, the variable values. So now variables can be inserted in a string with curly brackets. Only inside these brackets add the variable name. So to make it look a little bit nicer, in the end, add an underscore, and then the value would be a little bit more splitted from the name. So click on Save. And if you now go back to the macro execution control and highlight the workshop 2 and click on parameters and make sure that you've all that you have still the list 10, 40, 70. Click OK and click on Run. So now we are not asked to rename it, to backup it or override it. Because now if we go back to our project folder, we see here with the underscore the 3 new result folders, and here the 3 new result files, and you see that automatically here the 31% value is added to the result file name, as was our goal. So next, we want to add a second variable to our workshop 2Py macro, because the goal would be to use vary macro now to create structures not only with different solid volume percentage, but also with varying fiber diameters. So go back to our workshop 2Py, saved under a new name, with file save as, workshop 3, if we don't overwrite our other macro files. So again, make sure that you save the macro in your project folder and as a Python file. Click Save. And now to the job. First we could change our description. Vary the parameters solid volume percentage and fiber diameter. And then here in the variables section, change the number of variables to 2. And then copy here the variable 1. Make sure that you have the closing curly bracket here inside, but not the last one, because this one belongs to the whole variables block. We only want the variable 1. Then copy it and insert it here right below it, but in front of the last curly bracket. Change it to variable 2. And the name of this variable would be FD, which stands for fiber diameter. And the label would of course be fiber diameter. It's still a floating point, so double is okay. The unit will be in meter, which is the default here below in the dictionary, as we will see later. And as a tooltip, we can enter fiber diameter for material 1. And as a built-in default value, we will take the value which is in the dictionary below. We will see later the 1e minus 5. This means that the fiber diameter would be by default 1 times 10 to the power of minus 5 meter, which are 10 micrometers. So we will simply delete the check line because it's optional, not so necessary for this case. Yes, so now the new variable would appear in the user interface, but we also have to add it to the dictionary here below. The default fiber structure in GeoDict consists of 2 fiber types. And the first one would be described in the generator 1 section, and the second in the generator 2 section. We only want to change the fiber diameter of the first fiber type, so we have to look for the generator 1, which is here in line 171 for me. So here we have some information about the material of this first fiber type, the percentage of fibers with this fiber type, which is 50%, so 50% are fiber type 1 and 50% are fiber type 2. Which type of fibers? Here the infinitive circular fiber generator, so it are infinite circular fibers. And here is what we need, the diameter distribution. And by default, it's only a constant value for all fibers of this type. So all fibers have a diameter of 10 micrometers. So we have to change here this value to GDFD. And of course, we also have to change the result file name again. So yeah, also add GDFD inside curly brackets. And then we can save this file. Now we can see the benefits of adding a second parameter to the macro. We can now vary both parameter values automatically. So go back to the macro execution control. Click refresh, and the workshop 3 appears. You still see the fiber geo command. And if you click on parameters, now you have the 2 variables. And for solid volume percentage, we will again use the values 10, 40, 70. And now for fiber diameter, we will choose the 3 values 1e minus 5, so 10 micrometers, comma 2e minus 5, which would be 20 micrometers, and 30 micrometers, so 3e minus 5. So now when running a parameter study, the macro is executed once for all combinations of values from the 2 lists. That would be the cross product of the two value lists. So if you now click OK and click Run, so here in this slide we can see a 2D visualization of the resulting structures. As we had 3 values for both variables, the result is 3 times 3, so 9 different structures. We can see all combinations of solid volume percentage and fiber diameter. The solid volume percentage increases from top to bottom, and the fiber diameter varies from left to right. They all have a somehow similar structure with one fiber in the upper left corner and here the 2 in the center. This is because all structures were generated with the same random seed that controls the random numbers used for structure generation. This value also could be changed to obtain more different structures. But here we want to have a nice visualization of the impact from our 2 variables. For example, observe the single fiber here in the upper left corner. It becomes bigger from left to right with increasing fiber diameter. Also, the number of fibers increases from top to bottom to reach the given solid volume percentage. So now we go to our project folder, and because the next step would not be visible in the project folder, we delete all these result folders and result files that we generated now. They can be reproduced whenever needed, so it's no problem to delete them. So here these 9 folders with the 2 variable values, and now the 9 result files, and simply delete them. If you now go back to the macro execution control, and highlight workshop 3 and click on parameters. So we see here on the right we have the 2 pull-down menus for variation. With these pull-down menus we can couple these variables. So here, for example, we would see the fiber diameter, and here we see the solid volume percentage, and now we can choose one of them to couple it with the other. So if here now stands solid volume percentage, and then the macro is executed only for the pairs of the 2 variables. So only for 10 solid volume percentage with fiber diameters 10 micrometers, and then for the pair 40-20 and 70-30. So we click OK, click on Run. If we now look into the project folder, we only find 3 new result files and result folders for the value pairs we entered in the parameters dialog. Now on this slide we see now again a visualization of the results in 2D. In contrast to the previous macro execution, now only 3 of the 9 combination possibilities were generated, which we can see here in the diagonal. That is because only the value pairs were used instead of the cross product. This is the end of part 2. We have seen some Python language basics as 2 types of text output. We've seen variables and string operations. Also, we added a second variable, and we did parameter studies, one with the cross product of the entered value lists for the 2 variables, and one with the coupled pairs. Now it's time for another break, which gives us time to answer your questions. The last part, where we will see how to access simulation results and save images, will start in another 10 minutes.